Okay, welcome back for part 2. So we're going to start on number 21. So it says, consider the equation. What's a possible correct first step in solving this equation? So this problem actually has many things that you could do on the first step. We just have to decide what did they try to do in their multiple choice questions, and did they do it correctly? So for this first one, we still have our 2x plus 3, that didn't change. Our negative 2x plus 1, that didn't change. And then we got negative 4 plus 1. So we got rid of this positive 7x, and we changed that 3x. How did we do that? Well, they just subtracted the 7x over. 3 minus 7x is negative 4x, and then they brought the negative 1 down. That is correct. That is a legit step that you can make first. So if that's correct, why are the others wrong? So on B, you still have the same 2x plus 3. Then you have negative 2x plus 2. So what they did here is distribute. When you distribute this, you have to carry the negative with it. So this is negative 2 times x, which is negative 2x, negative 2 times 1, which is negative 2. So they distributed, but did they distribute correctly? No, they got positive 2 because they didn't distribute that negative. So that's incorrect. This one, they did the same thing. They distributed that second parenthesis, but again, we're supposed to get negative 2x minus 2. They got minus 1. So they distributed the negative, but not the 2. So that one's incorrect as well. For D, they distributed the first parenthesis, so 2 times x is 2x. 2 times 3 is 6. Is that what they got? No, they didn't distribute it out to the 3. So that's why that one's incorrect. So the answer is A. Okay, 22. Golf tournament awards prizes based on the finishing places. Let X represent the finishing place and Y represent the prize. So for X is greater than or equal to 1, which equation best represents the relationship between finishing place, X, and the prize, Y? So we have multiple different types of equations here. We have exponential, we have linear, we got another exponential, and another linear. What type of graph do we have? We have an exponential curve, so that's an exponential graph. So B and D cannot be our answers. So then you can make your table to find your multiplier. So we got 1/16,000. We have 2, so it's 1/16,000, 2 8,000, 3 4,000, and 4, that would be 2,000. And then everything else is not on a point. So how do we find our multiplier? We divide up. 2,000 divided by 4,000 is a half. 4,000 divided by 8,000 is a half. 8,000 divided by 16,000 is a half. So our multiplier is 1/2. Well, that doesn't help us determine our equation because they're both 1/2. So we need to determine which one is our y-intercept. So our y-intercept is always going to be on the y-axis. It's always going to be at 0. Even though this says x is greater than or equal to 1, that's just saying you have to have at least first place. However, your y-intercept is still 0. That does not change. So how do we get that y-intercept since it's not on the graph? We're just going to divide up by 1/2. So 16,000 divided by 1/2 is 32,000. So that means our answer is A. Give me 1 second, somebody's at my door. Okay. For 23, a student is completing the square for a quadratic function and has found that x squared minus 18x equals 32. Which step should the student complete next? So when you're completing the square, you want to find a perfect square root that completes this equation. So you have to get this bad square root out of the way. We don't know the square root of 32. And we want to find a perfect square root. That's where we put those blanks in on the lesson. How do we find that perfect square root? We take our middle number, we divide it by 2, and we square. Negative 18 divided by 2 is negative 9. Negative 9 squared is 81. So your next step would be to complete the square, to find that perfect square, and then put it on both sides. So we're going to add 81 to both sides of the equation, and that should be your equation. X squared minus 18x plus 81, that's what we got. And 32 plus 81, that's 113, which is what they got here. So our answer is B. Okay, 24. A fence building company is designing a fence for a client's rectangular yard that maximizes the enclosed yard's area with 120 feet of fence. The fence will connect to the back of the house, which provides one side of the rectangle. The company's graph modeling the area, which is A of W, of the yard with a width, that's a W, in feet is shown here. So we have our area and our width. So, which statement about the fence building company's model is true? The area of the enclosed yard increases for fence widths between 0 and 1800. So we're looking at widths between 0 and 1800. So starting on our width is 0. Does it increase until it gets to 1800? So it increases on width. Again, we're on width. So it increases until it hits this. What's our width at the top of that? Our width is the x value. So that is 30. That's your width. It is not 1800. 1800 is your area. So this is not increasing until it hits 1800. Your width is only increasing until it hits 30. And then it goes back down. So this one's wrong. The width of the enclosed yard should be 30 feet to maximize the enclosed yard. So again, we're talking about width. We're talking about x. Should it be 30 feet to maximize the area? What is maximize? That's your vertex. Is your vertex a width of 30 feet? Well, that would be this point at the top, that maximum. Is your width 30 feet? Yes, remember x was our width, so this one is correct. There's only one width of the enclosed yard that creates an area of 1,200 square feet. So we have an area of 1,200, so that's going to be our y-axis. Change colors. We don't know where 1,200 is, but we know the top is 1,800, so I'm going to estimate it to be right here. So is there only one width for that 1,200? It says we only have one width. No, we have one on the increase side and one on the decrease side. So we have two widths. So that one's incorrect. To maximize the area of the enclosed yard, the client needs 1,800 feet of fence. Now this one's a little tricky because your maximum up here is 1,800 feet. However, the 1,800 feet is the area. So if you're looking at a rectangular yard, the 1,800 feet is all of this inside. All this is talking about is 1,800 fence for the fence. The fence is just the border. The border of your rectangle, that's your perimeter. That is not area. Also, you could go back to your word problem. It says up here that they're designing a fence for a client's rectangular yard that maximizes the enclosed yard's area with 120 feet of fence. So only 120, not 1,800. So that's why that one's wrong. So our answer was B. Okay, 25. A student has $248 in the bank account that earns no interest. The student deposits an additional $20 each week with no withdrawals. The function f of x equals 20x plus 248 represents the amount of money in the account where x is weeks. How much money will be in the account after 1 year, which is 52 weeks, representing f of 52. So x is in weeks, and then your y is your money, because this represents the amount of money. We have our slope, we have our y-intercept. We want to know what it's going to be in 1 year, in 52 weeks. So how do we figure that out? This f of 52 over here, this is telling you where you see x, plug in 52, because it's x because that's what's in parentheses. So we're going to change that x to 52. And then we plug it in our calculator, and we're going to get 1,288, which is D. Okay, 26. The graph shows the height of a young gorilla during the first 10 months of life. So when is the gorilla's height increasing the fastest? So increasing the fastest just means find your slope between whatever time they ask for. So we want to look 0 to 2, so right here. So it's not exact points, but we're going from 40 to probably 57. So I would say that's about 17, and that's 2 months. So about 17 centimeters in 2 months. That's going to be 8.5. And then between 2 months and 4 months, it's going from about that 57 to maybe 67. So about 10. And we're still looking at 2 months. So 10 over 2 is 5. Between 4 months and 6 months, so 4 to 6, I'm going to start about that 67-ish. And it just goes up a little bit, so maybe like 72, 73. So I'm going to say maybe about 5, and it's still 2 months. Just estimating, it didn't have to be exactly perfect. So 5 over 2 is 2.5. And the last one, from 6 months to 8 months, I'm going to go back to that 60 or 72-ish. Oops. And that one actually does hit 80. So about 8 and 2 months. So that's approximately 4. So which one of these is going the fastest? That's going to be A. Again, you don't have to have the exact numbers, just estimate it. And the one that went up the most within 2 months was A. Which statement about f of x equals x squared minus 4x minus 12 is true? So they all say these can be factored. So we need to factor. How do we do that? Factoring is just your snowflake method. So on top, you're going to put a times c. So 1 times negative 12 is negative 12. B for the bottom, which is negative 4. And then ax on the sides. So 1x. Then we just take our top number. We divide it by x. Divide by x plus x. Oops. And we're going to look at our table. And we're going to find our bottom number, our negative 4, in the very last column, which is going to be 2 and negative 6. And we make our factors. There's no simplifying because these are 1. So our factors are x and a positive 2, and x and negative 6. So just knowing this much, what can we eliminate? We can eliminate C and D because those are backward. So we know A and B are correct so far. The function has zeros at what? X equals negative 6 and 2 or negative 2 and 6. So we need to find our zeros. How do we do that? We're going to set them equal to 0 and solve. So for the first one, we would subtract 2, and then we would add 6 over. So which one do those match? Those match B. So B, because A is backward. So just factoring and zero product property. 28. An athletic club buys car magnets and pom-poms for club members. The car magnets cost $4.95 each, and the pom-poms cost 85 cents each. The athletic club spends a total of $580 before tax on a total of 300 items. Each club member should receive 1 car magnet and 2 pom-poms. If X represents the number of car magnets and Y represents the number of pom-poms, which system of equations represents the situation? So we know X is the magnets and Y is the pom-poms. So let's reread this information. The car magnets are $4.95 each. So $4.95 for X, for car magnets. Pom-poms are 85 cents each. So 85 cents for Y. The athletic club spends a total of $580. Your dollars are going to go with your money equation. So this is all going to equal 580. Now do we add or subtract? Think about if you buy stuff. If you buy magnets and you buy pom-poms, they're going to add all of your costs together to get that 580. Okay? Then each club member should receive 1 car magnet, so 1X, and 2 pom-poms, so 2Y. And they got a total of 300 items. So these are your items, so that's going to be 300. And again, if you're buying stuff, you're going to add it up. You're not going to subtract it. So which equations does this match? Well, the first ones have negative on both. B has a negative. C has a negative. D is the only one that's all adding, and everything's in the correct order. So D. 29. A rectangular pool has a length that's 6 feet longer than its width. A landscaper creates a 4-foot wide walkway around the pool. Which equation represents the new area in of the pool and walkway combined? So area is length times width. You're going to have a formula sheet. It's on the Schoology page where you can find all your formulas that you may need for tomorrow for your Case 21. So what do we have here? We have a length that is 6 feet longer than the width. So your length longer than means add. So you have your 6 and your width. This than word, that's a switch word. That means flip this problem around. So instead of 6 plus W, it's actually going to be W plus 6. So that's our equation for length. So here's your length, W plus 6. And our width is just W. That's all they gave us for that. So we want the area of the pool and the walkway. So for our width right here, for the whole width, we have W in the middle. Our walkway at the top, well, that's 4 feet. Our walkway at the bottom, that's 4 feet. So this whole walkway, this whole pool is 4 feet at the top for that walkway, plus your width of the pool, plus the walkway at the bottom. So W plus 4 plus 4, which is W plus 8. That's your width. This is W. Your whole length down here, I'm going to change colors, of the whole entire thing, you have W plus 6 in the middle, but then you have a walkway on this side that's 4 feet. You have a walkway on this side that's 4 feet. So the whole length of the whole thing is 4 plus W plus 6 plus 4. So the walkway plus the pool plus the walkway. That one's going to be W plus 14. That's your length. So then let's just plug it in. What did they give us for area? They told us our new area is N. Our length, we added all that up and got W plus 14. Our width, we added all that up and got W plus 8. So what does that match? That matches D. Okay, 30. A movie theater records the number of buckets of popcorn sold based on the number of tickets for each movie. The table shows the results, which can be approximated by a linear function. If 270 tickets are sold for the next movie showing, about how many buckets of popcorn are expected to be sold? Now, if you look at this table, we are looking at a linear function, but our numbers are not in order. It goes from 100 to 300 to 200 to 300 to 200. It's all over the place. So the first thing that you really should do here is put these in order. So that's what I'm going to work with first. So I'm going to go least to greatest. Our lowest number is 106.21. Then we got 134.25. What's next? 234.40. 251.43. And we want to figure out what 270 is. So I'm going to keep going until I hit 270. Then we got 294.49. And you could keep going. It would be 326.54, and then 382, 385, 412. But all we need is 270. And we've already passed 270. Where would that fall? 270 would be right here between 251 and 294. So how many buckets would we have? We would have between 43 and 49. So which one of our numbers is between 43 and 49. Right, B, 46. So that's approximately how much we would have. Just put them in order and estimate. Okay, 31. Considering this function, since it can be rewritten as 2 times x minus 4 squared plus 1, which statement is true? It has a max or a min at one of these points. So does this have a max or a min? Well, how you're going to tell this is you're going to look at your x squared. It's positive, which means our graph is going to open up. So that curve is at the bottom, so that's a min. So we know it can't be A or B. If you were confused and you weren't exactly sure, you could always graph this. You can do either equation and graph it in here, plus 33, and you can tell that it's going to be a min. But where is that min? Well, that comes straight from your equation. This is what we worked on in class the past couple days. You're going to take the opposite of the parenthesis, and you're going to keep the last number. So it's going to be a positive 4 and a positive 1, which makes that D. If you forget that little trick, you can always look at it in your calculator. Second, trace min, follow the directions on your screen, and you're still going to get 4, when you round that off, 4 and 1. So it should be D. The table shows several values for a relation based on the table which is true. The table does not represent a function because for each x value because there's exactly one y value. Or the table does represent a function. So is this table a function? When you look at function or not a function, you want to look at just your x's. Are they all different? We got -4, -2, 3, 6, and 9. Those are all different. So this is a function. You could also plot these, just draw a little graph and plot them. -4, -12 would be here. -2, -12 would be here. 3, -12, 6, -12, and 9, -12. And you could do your vertical line test. And every single one of those would only hit one dot at a time. So you could do it that way. So this is a function because it passes the vertical line test. All of your x's are different. So that eliminates A and B. But is it a function because for each x value there's only one y value, or for some x values there's more than one y value? Well, a function is a function because they're different. So they can only have one y value. They don't get to share. So this is C. (33) The sequence shows the population of ducks on an island after 1, 2, 3, and 4 years. If this pattern continues, which function could be used to find the population of ducks after n years? So if we look at all of our equations are exponential, which means to find our multiplier, we're going to divide. So 864 divided by 144 is 6. 144 divided by 24 is 6. 24 divided by 4 is 6. So our multiplier has to be 6. Now remember, when you're looking at exponential, the first number is your initial. The second number with the x is your multiplier. So our second number has to be 6. Our first number is our first term. Our first term in our sequence is 4. So which equation matches that? C. And if you had done this problem backward and done the first term first, that's the only one with the 4 in the first term. So that would have eliminated everything right off the bat. Which graph has a maximum at -1, 1 and a y-intercept at 0, -2? So a maximum is going to be at the top of your graph. So that eliminates A and B. And we want that maximum to be at -1, 1. So we're going to go left 1 and up 1. So this one goes right 1, up 1. That's +1, 1. D goes left 1, up 1. That's -1, 1. So C is wrong because it's not -1. And you can always double check your y-intercept. That is at -2. So D is your correct answer. 35. A bookstore has 75 copies of a best-selling book on a table display. The bookstore also has X boxes, each with 40 copies of the book in a storage room. Which statement is true? So the total number of copies of the book is best represented by a linear function. The total copies is best represented by a linear function, a nonlinear function, or a nonlinear function. So first of all, is this linear? To be linear, it has to move at a constant rate of change. So we have 75 copies on the table display. That's how much we're starting with. And then they have X boxes that each have 40 copies. So this box has 40 copies, this box has 40 copies, this one. Is that a constant rate of change? Is it the same every single time? Yes. So that means this is linear because it's the same every time. So C and D are out. Is it a linear because the number of copies changes at a constant rate based on the value of X? Or because it does not change at a constant rate based on the value of X? Well, we just said this. Each box has 40. That's constant. That's the same. So this is A. Linear is always a constant rate of change. 36. Consider the figure comprised of an equilateral triangle, which is this top part, and a square. The perimeter of the figure is represented by P equals 10x. What's the equation of the perimeter when solved for x? So they already did the perimeter for you. All they want you to do is solve for x. So what do? Well, this is 10 times x. So how do I get rid of times x? What's the opposite? Divide x. Divide 10. P over 10 does not simplify, so that just stays how it is. That's solved for x. And that'll be C. Looks really complicated because of that picture, but don't let the picture fool you. They're actually oftentimes more simple than they look. 37. A caterer charges a flat delivery fee and a cost per sandwich ordered. The expression 35 plus 5.25x represents the total cost based on the number of sandwiches ordered. Which two statements are true? So we're going to have two answers. The cost of 6 sandwiches is $5.25. The cost of 6 sandwiches is $35. So how much is 6 sandwiches? Well, if we plug in 6, we're going to get 66.5. So actually, neither of those is true because 5.25 is your slope. That's the one with x. And 35, that's the one by itself, that's your y-intercept. So neither one of those is going to be your 6 sandwiches. So those are both wrong. The cost per sandwich is $5.25. Per is a special word. I call it a slope word. So that tells us we are looking at slope. Is $5.25 your slope? Yes, that's the one with x. So that is correct. But we have two answers. Is the flat delivery fee $5.25 or $35? Well, your flat delivery fee is going to be your initial value. Your initial value here is $35. $5.25 was your cost per sandwich, your slope. So your flat delivery fee, your initial is $35. So C and E. 38. In order to solve the equation x squared equals 3x minus 2, a student graphs y equals x squared, which is this side, and separately graphs 3x minus 2. Which statement is true? The only solution to the equation is 1. The only solution is 2. Or they have two solutions at x equals 1, x equals 2, or x equals 1, x equals 4. So you can do this multiple ways. What I would do and what I suggest is to do what the student did. They graphed it. So we're going to graph x squared and 3x minus 2. And you can see where they cross. So we do second chase 5 to find their intersection points. And just enter until you see the word intersection. So we know it crosses at x equals 1. But is there another one above that? Because it's still hitting somewhere. So let's try it again. Second chase 5. Scroll up, see if we can get this one. And it actually does hit again at 2. Now this is 2, 4, and that's where it's going to confuse some of you. The question is looking at x's. X's are your solutions. So we know it's got two solutions, but is it 1 and 2 or 1 and 4? Remember, your x's are your solutions. 4 is a y value. We want the x value. So we want 2. The rest of this is just plugging it in. You could actually plug your numbers all into the equations and see if it gives you a true statement. So if we plug in 1 to both of those, 1 squared is 1. And then if we do it to this equation, 3 times 1 minus 2 is 1. And 1 does equal 1. That's correct. If we do it to the second equation, the second x value, for 2 squared, that's 4. If we plug it into the second equation, 3 times 2 minus 2 is also 4. So you can either graph it, or you could just plug the numbers in and see which ones are true. So this one is definitely C. 39. Consider the table. Which equation best represents the relationship in the table? So we have two linear equations and we have two exponential equations. One second, double check this. Yes. So if it's linear, it's going to subtract up. That's linear. If it's exponential, it's going to divide up. So if we subtract up, 1,024 minus 256 is 768. 256 minus 64 is 192. So they're already different. So that doesn't work. Definitely not linear. So let's try to divide. 1,024 divided by 256 is 4. 256 divided by 64 is 4. 64 divided by 4 is 16. So why did it change? Because that means it's not either. Well, you have to check the other side as well. 3 divided by 3 minus 2 is 1. 2 minus 1 is 1. 1 minus negative 1 is 2. So it's a different interval. The bottom two are on an interval of 1. The top is on an interval of 2. And the square root of 16 is 4. So that's the same thing. It's just on a double interval. So it's got to be exponential. So A and B are out. We know our multiplier is 4 after we simplify it. That doesn't help us because they're both 4. So what's our initial? 64 or 16? Where do you find your y-intercept? You find your y-intercept at 0. So 0 is going to be between -1 and 1. So how we get that is we just divide up by 4. 64 divided by 4 is 16. So our y-intercept is 16, which is C. Okay, the last one, one second. Consider the systems of equations. Which shows an equivalent system of equations? So all of these first equations, if you check them out, they're all the same. They're the same as the original, but they changed the bottom equations. They're trying to do elimination here. There's a lot of different ways you could do elimination, so let's see what they did and see if they did it correctly. So the first one, they took our x and they made it -5x, which means they multiplied a -5. So if we multiply -5 by all of this, we get -5x, -10y, and a +60. Did they multiply that out correctly? Yes. So this one checks out. Let's double check it though. What did they do on the second one? They changed it to 5x, which means they multiplied out a 5. So 5 times x is 5x, then 10y, and a -60. Did they do that one correctly? No, because they got +60, which is wrong. It's supposed to be negative. The last one, C, they changed it to 2x, so they multiplied by 2. 2 times x is 2x, 2 times 2 is 4y, 2 times -12 is -24. Did they do that one correctly? No, because they got -14, which is wrong. The last one, they changed it to 2x as well. So it's the same problem, but why is that one wrong? Because they put they put +24, and it's supposed to be negative. So that's why that one's wrong. So your answer is definitely A. So remember, your case 21 is tomorrow on Wednesday, March 3rd. You have to take it during your scheduled class block. So make sure you wake up in time to take it. Make sure you set an alarm or something so you know to take your test. And use any shortcuts you can. If you can use your calculator, use your calculator. If it's just knowledge that you know, use that knowledge. Double check yourself. Good luck on your test. Do your best.